This video is going to be covering lesson 5.1, which is about exponents, and using those rules of exponents to simplify. Our first example is going to be around the product rule. Then we'll also look at examples that use the quotient rule, then we'll go through the zero power rule, then we'll talk about the power to power rule, then the product to power rule, and then finally the quotient to power rule. And then we'll actually look at examples that involve all of these rules in one problem. So this first one, again, is just asking us to simplify using the product rule. So we have x squared times y to the seventh. That whole quantity is being multiplied by this factor here of x to the fourth, y to the third. So to start this problem, my advice is to rewrite this without the parentheses. We really don't need the parentheses since this is all multiplication. So we can rewrite this as x squared times y to the seventh times x to the fourth times y to the third. In order to use the product rule, we do need to have it so that they have the same base. So what we can do, since multiplication is commutative, we can rewrite this so that our bases that are the same are next to each other. So let's rewrite this as x squared times x to the fourth times y to the seventh times y to the third. Essentially, we're just flip-flopping those two spots. Then, now we can actually apply that product rule. Focusing on the x squared times x to the fourth, the product rule tells us that if they have the same base, we just need to add the exponents to simplify this. So this is going to turn into x to the sixth since 2 plus 4 is 6. Then, over here with the y's, we have y to the seventh times y to the third, and so this is going to end up being y to the 10th. And then that would be our final expression, because that is as simplified as you can get. Now we have an expression, they don't have the same base, and so this would be it for this question. Our next example is question number 8 out of the book, and this is another one that's going to be very similar. It's asking us to, again, simplify using the product rule. So they're having us focus on just one rule at a time as we go through these first few examples, and then we'll look at problems that, again, involve all or, most of the rules at one time. So with this problem, just like the last one, I would take the time to rewrite this without the parentheses because, again, they're not needed since everything is technically being multiplied together. So we can rewrite this as -6 times p squared times 5 times p to the fourth times 2 times p to the third. So essentially we're just expanding it. Just like the previous problem, and when you guys do this on your own, you don't have to necessarily do this next step, but for the sake of the notes, we're going to take the time to rewrite this so that all the like factors are near each other. So we're going to rewrite this so that all of our constant factors are out front. So we'll have -6 times 5 times 2, and then we'll rewrite all the variable factors, p squared times p to the fourth times p to the third, at the end. Using our product rule, that's going to help us to simplify this part of it. And then this part here with all the constant factors, we just need to multiply those together. -6 times 5 times 2 is going to be -60. And then using the product rule here, since they all have a base of the variable p, we're going to add all of our exponents together. So 2 plus 4 plus 3 is going to make 9. So this is going to end up being p to the 9th power. And this would be our final answer. And so that's the simplified form of this expression here. This next example is going to be having us use the quotient rule. So the quotient rule is when we have division taking place. So this giant fraction bar is indicating division. And just like the previous problem, I'm just going to take the time to rewrite this just so that it's a little bit further apart so that we can see what's going on with each of these different parts of this quotient. So I'm going to rewrite this as 60 times a to the fourth times b to the 13th. So same problem, just adding some multiplication dots in there so that it's expanded, a little bit more space between the numbers and the variables. And then rewriting the bottom, the denominator. So we have 60 times a to the fourth times b to the 13th over 12 times a times b to the 9th. And we're being asked to simplify this. So to simplify this, we can focus on each of these different parts. So 60 divided by 12, we can actually do that. A to the fourth over a, we're going to use the quotient rule for, and this b to the 13th over b to the 9th is also going to be able to be used with the quotient rule. 60 divided by 12 is actually just 5. So if that ended up being a fraction, we would just, again, simplify the fraction as far as possible, but this actually just is the whole number 5. And then a to the fourth over a, we need to keep in mind that this is a to the first power, and so when we subtract our exponents, just like the quotient rule tells us, 4 minus 1 is 3, so this is going to be a to the third. B to the 13th over b to the 9th. We're going to subtract those because that's what the quotient rule tells us to do. And this ends up being b to the 4th. And this would be the final answer for that example. Our next example is number 16, and this one again is asking us to use the quotient rule to simplify. So just like the previous problem, let's rewrite this just so that things are spaced a little bit more apart and it's not so congested over here when we go to draw our circles of what we're going to be grouping together. So this is going to be a good example of a question where we do end up with a fraction instead of a whole number like on that previous question, which is okay, that happens sometimes. So this 10 over 15, we're going to be able to simplify that. We're going to be able to simplify these m's and these n's using the quotient rule. 10 over 15, that is just the same as 2/3, right? 10 and 15 both be divided by 5. That's going to turn into the fraction 2/3. Then we have m to the 21st over m to the 13th. So we can actually do the subtraction here. So 21 minus 13 is going to be 8. So we're going to have m to the 8th. And then n to the 9th over n squared. Again, we're going to subtract those exponents. So this is n to the 7th. So that would be our final answer. You could also write this as 2m to the 8th n to the 7th all over 3. That would be the same exact thing, and that could come up from time to time as you go through these questions, or if you go to check your answers for some of the odd questions in the back of the book, they might write it more like that. Our next two examples are number 20 and 22 out of the book, and these are actually having us use the zero power rule. So anything to the 0 power is equal to 1. This is something that we brought up during one of our earlier classes in the year. It was back in chapter 1. And the idea behind this, that if it's to the 0 power, again, it equals 1. So for this first question, we do need to be careful because the 6m is not in parentheses, so only m is being raised to the 0 power. So this here, m to the 0, is going to be equal to 1. So this is going to be 6 times 1, which is just 6. And so this expression here simplifies down to 6. For this question, number 22, we have 3 times p to the 0 plus 2 times q to the 0. Again, the whole quantity is not to the 0 power, it's only the variable. So this is going to turn into 3 times 1, since p to the 0 would be 1, plus, then we have 2 times, and then q to the 0, also 1. Simplifying this now, 3 times 1 is 3, 2 times 1 is 2, and then 3 plus 2 is 5. So that's the 0 power. Number 26 is going to be asking us to simplify using the power-to-power rule. So this is the most complicated one out of the 4 questions that they have for examples or practice problems in the textbook. And essentially, it's just a power to another power. So it really doesn't matter the order that you do this, but I'll start inside the parentheses. So inside the parentheses here, we have m to the 4th to the 5th. And our power-to-power rule tells us that we're going to multiply those two exponents. So m to the 4th to the 5th, that's the same as m to the 20th. And so this now is being raised to the 3rd power. M to the 20th to the 3rd, again, that's another power-to-power. So we're going to multiply those two, and our final simplified expression is going to be m to the 60th. The next 2 examples have us using the product to power rule. So these are questions number 30 and 32 out of the book. And this product to power rule, we have a product inside of the parentheses. So I'm going to rewrite this just so that it's a little bit more in its expanded form. So times and then t to the 6th to the 4th. So we have this product here. So it's a product to a power. And essentially what you're doing, you can almost think of it as you're distributing this exponent to everything that's inside the parentheses, all those different factors. So this is going to end up being negative 5 to the 4th times t to the 6th to the 4th. And that t to the 6th to the 4th power, that's just like we saw in the last problem. So that's actually going to be using the power-to-power rule to simplify. Before we get to that, though, let's talk about what this negative 5 to the 4th is going to be. So negative 5 to the 4th means you're going to be doing negative 5 times negative 5 times negative 5 times negative 5. So negative 5 times itself 4 times. That's going to be positive 625. T to the 6th to the 4th, again, the power-to-power rule tells me that we're going to multiply those exponents. So this is going to be t to the 24th. And that's our simplified expression. 32 is a little bit more involved than number 30 because we have a lot of factors going on inside the parentheses. So again, I'm going to take the time to just rewrite this. You don't have to necessarily do this when you work on the practice on your own or when you guys do the quiz or even when you take the test, but it's not a bad idea just to help keep your work a little bit more organized. So after we get to this point and I rewrite it, basically, again, what we're doing is we're taking the exponent on the outside and you're going to give it to every single factor that's on the inside of the parentheses. So we're going to have 2 to the 4th times, and then this is going to be x to the 3rd to the 4th times y squared to the 4th times z to the 4th. So this is another one where we see that we're going to be using that power to power rule, and that's why a lot of these problems do actually involve more than just one rule at a time, especially as they get a little bit more complex. So going through and simplifying this, 2 to the 4th again means you're going to do 2 times 2 times 2 times 2, which is 16. So this is going to be 16 x to the 12th, because we're going to multiply, y to the 8th, and then z to the 4th. And that would be the final expression for this problem. The next two examples, which will also be the last two examples for this video, and then there will be a part 2 that will go over the ones that are going to be simplifying using just any of the rules for exponents, so it's not going to specify which one you need to use. These two last examples have to use the quotient-to-power rule. So we have a quotient, so again, what looks like a fraction, and that's all being raised to some power. It's very similar to how we did this last problem, where basically you're going to give this exponent to the numerator, and you're also going to give the exponent to the denominator. So this is going to turn into m to the 4th to the 5th over n to the 3rd to the 5th. And now we use that power to power rule to simplify each of these. M to the 4th to the 5th is going to be m to the 20th, because again, you're going to multiply 4 times 5. N to the 3rd to the 5th is going to be n to the 15th. And that would be as far as we can go with that. Since these do not have the same base, we can't follow through with the quotient rule. That is as far as you can go. For 38, very similar idea, except for this one actually combines a little bit more than just the power to power rule. It's also going to include the product to power rule. But before we get there, let's use the quotient to power rule, which basically again tells us we're going to take this exponent and we're going to give it to both the numerator and the denominator of this quotient. So we're going to have 3p to the 4th to the 3rd all over 4q to the 5th to the 3rd. So again, we just basically distributed that to the top and bottom of this quotient. This is now where that product to power rule is going to come into play. So this is going to be 3 to the 3rd times and then p to the 4th to the 3rd, because again, we need to distribute to both parts of this factor. Same thing on the bottom. We're going to have 4 to the 3rd times, and this is going to be q to the 5th to the 3rd. Now, 3 to the 3rd, we can actually simplify that. 3 to the 3rd power is going to be 27. P, and then 4 times 3 is 12. So that's our numerator. And then 4 to the 3rd power is 64. And then 5 times 3 is 15. So this would be our final simplified expression for that problem.